This is hydrogen peroxide. It slowly decomposes to form water and oxygen. Any oxygen produced will be collected in the syringe, but at room temperature the reaction is so slow you'd think nothing was happening. One way of speeding up a reaction is to add a catalyst. Add manganese dioxide and the hydrogen peroxide quickly decomposes, producing oxygen. But is it the best catalyst for the job? To find out which of these catalysts speeds up the decomposition of hydrogen peroxide most effectively, the same mass of each is placed into a measuring cylinder. Iron oxide, lead dioxide, and manganese dioxide are the chemicals under investigation. A small amount of washing up liquid is added to make the production of oxygen more visible. The tube on the left is the control. It contains no catalyst. Finally, in goes the hydrogen peroxide. As oxygen is evolved, the washing up liquid forms a foam which rises up each cylinder. The rate at which the foam is produced is a measure of how effective the catalyst is. Lead oxide is much better than the rest. Specific catalysts are used to speed up specific reactions. Cobalt chloride solution is the catalyst in this next reaction. A catalyst is a chemical that takes part in a reaction but doesn't get used up. Look again at what happens to the colour of the cobalt chloride. At the end of the reaction, the pink cobalt chloride has returned to its original state. So the amount of any catalyst added to a reaction should still be present at the end. For this next reaction, we'll be using 0.25 grams of copper oxide. It acts as a catalyst in the thermal decomposition of potassium chlorate. The tube on the right contains the catalyst, the one on the left doesn't. As the potassium chlorate is heated, it decomposes and gives off oxygen. The quicker the reaction, the sooner the glowing splint in the neck of the tube will relight. The absence of a catalyst makes the decomposition to produce oxygen much slower. Filtration will recover the catalyst from the other tube. The mass of this filter paper is 0.83 grams. Water dissolves away any remaining potassium chlorate. But the black catalyst doesn't dissolve. Once the filter paper has dried, it's re-weighed. Its mass is now 1.07 grams. If the filter paper alone has a mass of 0.83 grams, how much of the catalyst has been recovered?